Hello and welcome back to Math Class with Mr. Kura. Today we're going to continue to talk about linear equations and word problems. If you didn't watch the previous video, it's kind of a prerequisite to this video. You need to watch that to figure out how to write the equations. Given a word problem, how do you write a linear equation? And then today we're going to take it to the next step and answer some questions using the equations that we write. So we'll quickly go through writing the equations like we did in the last video, but I'm not going to go quite as in depth as I did in the last one. If you would like to watch that, you can watch that. So Isabel went to the fair. It cost $7 to get in the fair and $3 per ride. So we're going to, this word per tells us it's going to be our rate. $7 to get in, that means it just costs her $7 one time. So that is the flat fee, or the B value, initial value in our problems. So our equation is y equals mx plus b. So our equation given this problem, this situation, is y equals 3x plus 7. So now let's answer the questions using this equation. How much would it cost to ride 14 rides? Oh, and one more thing we forgot to answer, or we forgot to put. So our x values equal, and y values, our x values here are number of rides. Y value is total cost, or total amount of money spent at the fair. So how much would it cost to ride 14 rides? We'll write our equation as y equals, that's what we're trying to find, the total cost. Y equals, m is 3. In this situation, our x is 14 rides. So 3 times the number of rides plus the $7 to get in. So 3 times 14, let's see, we get 42 plus 7. So 42 plus 7 is 49. Y equals 49. Well, what does y equal? Y equals the total cost. So it would cost $49 to ride 14 rides. $49 to ride 14 rides in that situation. Now, next one. How many rides would she go on if she spent $67? So what are we given here? Are we given the number of rides that she went on, like here? Or are we given the total cost? We're given the total cost. So we're going to rewrite our equation, but instead of replacing our x, we're going to replace our y. So 67 equals 3. Our x, we don't know. That's what we're trying to figure out. 3x plus 7. And then we would have to try and solve this. So to try and solve this, we'd say minus 7, those cancel. 60 equals 3x. Divide by 3, divide by 3. We're left with x equals 20, or x is the number of rides. So she would have to ride 20 rides to spend $67. Okay, we can do one more here. So we wrote the equation in the last problem, so we're not going to go into that too much. But so it costs $2 per mile. So the per tells us that's our M. Flat fee tells us that's our B. So our equation is y equals 2x plus 12. So I know I kind of jumped into it because we did it in the last video, but Bruce needed a taxi. It cost $2 per mile and $12 for a flat fee. We come up with this equation. Now the question's asking us, how much would it cost to go 11 miles? How much would it cost to go 11 miles? So here's where it's important that we write x equals x values and y. So what does x and y represent here? X represents number of miles. Y represents total money or total cost of this taxi ride. So what do we know here? We know 11 miles. Is it 11 miles talking about x or y? Talking about our x. So we'll rewrite the equation. Y equals 2. We said this is our x, right? So 2, replace our x with 11 plus 12. And then go through and start to simplify it. Y equals 22 plus 12. Y equals 34. So it would cost $34 to ride 11 miles. Okay, next one. How far did he go if he spent $72? So just like the last one, now we're given our y value, our total. So we're going to rewrite this equation. We're going to rewrite this equation as 72 equals 2, and we don't know x, plus 12. Then let's just start to simplify it. So draw our line, minus 12, minus 12. 60 equals 2x, divide by 2, divide by 2. X equals 30. So he went 30 miles to spend $72. Okay, thanks again for spending time in math class with Mr. Kura, and I look forward to talking to you again soon.